So hello everyone, this video is regarding induction hardening process. It's yet another selective hardening process. Okay, so let's start. As you can see in this picture, this process involves a steel specimen in the inductor coil, okay, that has several turns of copper tube. Okay, this is a copper wire and that's having several turns. Now this copper tube is acting as the primary coil of the transformer and will be water cooled. What happens when high frequency current is passed through the coil, it will set up a magnetic field that will induce high frequency eddy current and hysteresis current in the steel specimen. Resistance offered by the steel specimen to the flow of these currents through it will result in the rapid heating of the surface layers of the specimen. Temperature produced will be in the range around 800 degrees Celsius, which will cause the surface layers to change to austenite because it's at a very higher temperatures. Now at this moment the surface will be sprayed with cold water. This is water in for quenching medium to transform the austenite to martensite. So only the surface of the specimen gets hardened while the interior remains to be soft. Okay, so basically when you say induction hardening, that heating is by this induction. The name itself says that. Okay, so this is induction hardening. Now the next thing is age hardening or precipitation hardening. Now what happens, certain metals alloys happen to show increase in their hardness after allowing the sufficient time at room temperature. See, when you say age hardening, that word age, it mainly refers to time. So what we mean to say is hardening happening in the alloy over the period of time. Okay, strength developing over the period of time. As the alloy happen to age, the strengthening will take place, the hardening will take place. Okay, that is why we call it as age hardening. Now specifically we have age hardening in case of alloy, aluminium and copper alloy. Now there are three methods to it: solution treatment, quenching and aging. Now what happens is, firstly, solution treatment, the alloy will be heated to certain temperature. Okay, now in case of aluminium copper alloy, we have the alloy, aluminium alloy, mainly it has aluminium alloy with 4% copper. Okay, so what happens, that alloy is heated to 550 degrees Celsius and it is held for that temperature, wherein the diffusion will occur. Homogeneous solid solution of aluminium will be formed. Okay, hope I'm not confusing you. We have aluminium alloy with 4% copper, which is heated to about 550 degrees Celsius and held for certain time, so that diffusion will occur and a homogeneous solid solution is formed. Solid solution of aluminium and copper, that is. Okay, this is solution treatment, solid solution. Next is quenching, where this alloy, aluminium copper alloy, is quenched to about room temperature, okay, which contains more of the aluminium, and the quenched alloy is supposedly very soft. Okay, now what happens, quenching will cool the material so fast that the atoms of the alloying elements, that is in case of this it's copper, that will not have time to diffuse out of the solution. So precipitation will not occur. Solution is supersaturated. I hope you have heard about the supersaturation in BTD, if I am not wrong. Okay, so what happens, aluminium copper alloy, when the alloy is quenched, it has more of aluminium phase than the phase that has gone. Okay, like there is no time for copper to come out of aluminium phase. So basically it is having supersaturated. Okay, next is aging. Now what happens? The alloy is heated to temperature of about 165 degree Celsius and held at that temperature for 10 hours. So the precipitate of copper aluminium will come out of the aluminium phase of that is alpha phase over the passage of time. The resulting precipitate will be of fine particles, and such fine precipitate will give much stronger, harder alloy. This happens over the period of time. Okay, that is process where the solute particles diffuse out of the solution and into clusters that distort and strengthen the material, which happens over the prolonged time. That is why we call this as precipitation hardening. Okay, because strengthening of the alloy results as a result of precipitation of finely dispersed from supersaturated solid solution over the period of time. Okay, so this is about age hardening or precipitation hardening. Okay, in detail again it's in the slides. Please refer to it. Okay.